I'm Anup Gupta, and welcome to this session on, what are the technological things we can do to help in the area of education. Most of us are pretty, deeply into the research side of things, what we are doing, but I think a second really important role for all of us as faculty is around the teaching that we do. And we are in a time where technology is being discussed more and more in the academia every day to see how we can bring technology to bear, along with the human and the people aspects of it to enhance learning. So we're going to have three talks today. I will talk about something called Office Mix, which is more of a tools talk. And then I have two wonderful colleagues, Sumit Basu and Rakesh Agarwal, who will talk about some additional research. And in particular, we are broadly targeting, how MOOCs and SPOCs and blended learning and all of these things are coming together and how we scale. Sumit is a senior researcher in our machine learning group, and he will talk about power grading. That is how, if you start going into very large-scale audiences, how can you scale the grading process? And Rakesh, who's a technical fellow in our Silicon Valley labs, will talk about how can we automatically enhance textbooks to be much more engaging for students. So we have three parts. Roughly the way we are dividing up the time is I'll take around 40 minutes to introduce you to Office Mix. Most of the time is really going to be a demo and showing you how you can actually use it, because I think the power becomes much more evident from using it. It's a tool that can really enhance, and then we'll have roughly 20-25 minutes each for Sumit and Rakesh. So let's jump in about Office Mix. What Office Mix is really a solution built on top of PowerPoint, and PowerPoint is familiar to a billion people around the world, that really enables anybody to create online lessons in minutes in some sense, to share them, to see the analytics and all of these components brought together in a very, very simple package that is there. As I was saying, it's a tools effort, which is an enabling effort to each of you. It is also a platform, as I will talk about, where additional interactive simulations, et cetera, can be brought into the tool, and they become enabled now for every other faculty member, every other student to very, very easily exploit and take care of. So, basically three parts to the talk. I want to briefly, I have 4 or 5 slides to introduce Office Mix, and then I'm going to spend almost 15-20 minutes doing demos, showing you what you can do with it, and then we will basically summarize in terms of what are the scenarios and have a Q&A. Okay, so our goal is pretty simple in this particular case. Now, this is something most of you are familiar with at some level, on how education is getting transformed. We are still mostly in the traditional mode where most learning happens pretty much in lockstep, especially as we go through K through 12. It starts getting a little bit more flexible. It is a much more teacher, lecture-centric education, and we know there are limitations there. Static textbooks, there's not that much interaction. And the goal in some sense is how do you move to the right, where we can do much more personalized learning. If you think of Khan Academy or you think about mastery learning, how do you make sure you're mastering one topic to move on to the next topic? How do you make it, if you take any of the courses, in Coursera or edX, how do you pepper lectures that you have with questions along the way to make sure students are understanding? How do you make sure maybe they're watching them at home, and in the classrooms they're much more like recitation sections? So all of these things are coming together, and if you look at today's, whether MOOCs or SPOCs or flipped classrooms, blended learning, one component in all of these things relates to creating online lessons of some sort, okay? Whether they are 5-minute, 7-minute chunks like what Salman Khan does for K through 12, or they might be Coursera, edX, or all of the numerous things that are coming along. And what Mix is about in all of these is that it's hard to do this blended learning today. And what are some of the hard parts? So one is it's difficult to author online lessons, right? So if you create, and a lot of it becomes essentially video editing tools. And the way, I was talking to Anant Agarwal, who's a close, colleague of ours at Stanford when I was there, and so he was saying it's just so frustrating because he has to work with your videographer, right? So he does something, he does a take, he says, oh, I messed up, I want to do it again, and you're editing it. It's almost like you were, when I was doing my bachelor's thesis, you're in the typo, you had the typing pools. So, you wrote something and you took it to somebody else who was going and editing. And the friction was so high that you didn't make the changes versus, you got word processing and you did your own stuff. Okay, it's difficult to make them interactive in terms of polls, surveys, questions, interactive labs. And I will show you more instead of just talking here. It's difficult to share. You can't share just in YouTube. You do contracts with edX, Coursera, or somebody else. How do you just go and share this rich stuff? And how do you finally get analytics, right? When your students are taking it, how do you make sure, what are they doing? What can you do with it? And how do you get a much more composable model? Okay, so Office Mix tries to address many of these problems. So there are three elements we think about. One is, we were trying to say when these MOOCs are happening, what is the unique way in which Microsoft can contribute? Okay, and so one was people use PowerPoint, and if you take something familiar at, so you work in PowerPoint, the beauty also you get, as you will see, is that you can reuse a lot of content that you create. PowerPoint is like your source code, as I will show you in a little minute. You can record audio, video, ink. You can repurpose your existing lessons. You can add these quizzes, polls, interactive. The creation today is on Windows, but these can be consumed on any platform whatsoever that is there. And it's an extensible platform, so one of the things I will talk about is I'm looking at how can you and your graduate students further add to it so people in the field can build more interesting interactive lessons. And then finally, we have a bunch of stuff around, statistics and analytics that are available. So, our tagline in some senses, from PowerPoint to interactive online lessons in minutes, in some sense, how do we make it that simple? So there are three primary solution components that you'll see, and I'll talk about in the demo. And the next slide goes into the demo. One is authoring within PowerPoint, and we will cover that. The second is what is the consumption experience? So when a student is taking it, what would it look like to them? And the final thing is a portal where you manage, you decide how to share, where you go and see the analytics corresponding to it. Okay, so let's get into a demo of what we can do. So what I'm going to do is I'm just going to go into IE. So this is the portal. So the place where you go, you can access it today. There's a public preview, so officemix.com. Officemix.com is the URL where you need to go to access it. You can download a free add-in for PowerPoint to do it. So this is a public portal that we see. So we have a few categories. So this is a little bit like mini iTunes U or a mini YouTube where, you're posting your lessons that are there. For each lesson, you can look at how many views, et cetera, et cetera. Now let's go and look at a few, lessons on what does the created experiences look like. So the first thing I'll go to is Ohm's Law. Okay, so this is one of my colleagues at MSR did it. So
Hi,
it's loading.
my name is James, and I'm curious about electricity. Lightning bolts, Teslas, electric eels, circuit boards. Electricity is everywhere, but what is it? How does it work?
So as I go along, I can see there's a kind of a table of contents. You can look at the individual slides. So, I can just jump out here.
Ohm's law is very simple.
So what you're seeing is animations you were seeing. You're seeing inking happening.
V equals I times R. You're basically an electrical engineer now. So, for example, if you have a 9-volt battery and you have a 2 ohm resistor,
So
how much
just
current
rich inking
will
is
flow
happening.
through a
So I don't
Well,
think we need
know
to
that
learn
V
Ohm's law.
equals I times
You
R,
can embed
so
videos
using the magic
inside.
of algebra,
Actually, one thing I will show you, you can speed it up. I mean,
equals
that's kind
V
of a necessary thing in
divided by R.
almost
So in this particular example, I equals
any
9
lecture that
volts
you create
divided
nowadays.
by 2 ohms.
So this is, you can embed videos to keep your students excited if that is what is necessary. In this case, so what we have done is, so Touch Develop is one of the software packages that MSR developed for programming and simple kinds of things. So this is just showing one of the interactive, labs that I can embed. And so this is just says, if I take you to so there's a variety of things you can do. There's also quizzes that are embedded inside the thing, and I can go and try. I can try, this one, and it'll say wrong. This is the right answer. That is there. Every interaction that I am doing with the player is going to, and recorded at the backstop. So every seek that I'm doing, every pause I do, every going forward, it's going to the back end that can become analytics then for the teacher or professor on what they can do inside, and then I can go on. So that's one example that is there. So I'm going to skip past that. A second example that I want to show is actually this is also designed, in fact, one of our design points was how K through 12 teachers can go and do this, who might be very tech unsavvy, but this might also mean, something like a history. So this is a lesson done by a K through 12 teacher.
Hi, my name is Stacy Roshan. I am a math teacher who has been flipping the math classroom for a number of years
So,
now.
again, standard animation, etc. is that.
First, reviewing the relationship between radicals and rational exponents. Then we'll talk about how to rewrite expressions.
So again,
negative
shows you some
32,
animations.
raising that to the 1/5 power, since we're taking the 5th root. In this example here, they're asking us rewrite using rational exponents, which I just did, but they're also asking us to evaluate. So to evaluate the 5th root of negative 32, we want to ask ourselves, what times what times what times what times what equals negative 32?
Okay, just showing that, all of the simple things in writing that you might do, it makes it very easily. Let me just take you through a couple more. So, Phil Guo, who was at Stanford and then spent
from the University of Rochester. Today I'm going to
a year at edX, had done this Python tutor. So if you want to integrate in Python labs inside that, so he's done a bunch of that. So I'll show you a few labs. So what you see here, actually, these are the slide transitions that are there. So there's a natural granularity at which you see everything. And these other things here are the interactive labs. Okay, so let's go here.
Online Python PowerPoint.
And this thing, how you embed inside, which I'll show you later. But these are, just labs, and then I can go and actually, edit, and he's built some interesting frames inside that. So, here he wants to show you Python data structures, and I can go and, step through them. So, and he's going to make it just like if any of you have taken a Udacity Python course, you can go, interact, submit. All of these things that you're seeing essentially are HTML5, JavaScript frames embedded within PowerPoint. And again, I'll show you how you do it with a backend service that is connected to it. So any of your students, all of you can go and write and extend whatever is available inside. And then, as I'll show, it becomes as easy as inserting clip art into your PowerPoint to create these lessons on how you are stitching stuff together. So maybe a final example I had created, which captures more of the things. So I just yesterday night went and created.
Hello, I'm Anup Gupta, and I wanted to give you a quick introduction to features of Office Mix.
So, and this is just again
There are
showing
three
the animations.
components.
So
There's
this
really
is
a
the
large
set of
variety of them because we are in
9
PowerPoint,
capabilities that are built
automatically
into
get high fidelity
thing that is there. So one additional one I wanted to show is generally in videos, it's very hard to put hyperlinks, because it's just a video. Here, if you know how to do hyperlinks in PowerPoint, they work. So, I had just done a hyperlink here. And so, there I go. And I didn't have to do anything to change that. So, just hyperlinks inside your lessons, etc., just totally work. You can go and edit and change anything. So quiz we had already seen, so I don't have to do it. So we have, again, because K through 12 was a little bit of a focus for us, so all of the Khan Academy stuff can be directly inserted inside.
We will now say someone just said in another room, not looking at your plants.
And the beauty in some sense of this is that
central tendency.
Is that if you're using somebody else's content, you can provide the context around it. So I can put in the lesson. Now I'm going to make you see the Khan Academy video. Make sure to focus on minute 3 to minute 5, okay, and pay attention to this. So as a faculty member, you're not being substituted. You're contextualizing somebody else's great work. So if there's a great conference talk that you want to include inside your lesson, but then you want to contextualize it in the material you are creating, you are able to do that. Similarly, Khan exercises are totally available. So, it says, so the arithmetic mean is 1.3, then I can, start moving these things around, and I can do mean 1.3, okay? So these Khan Academy interactive exercises are also available, and we give you analytics back on how many attempts you did, or how did you track it, all of that is there. What else did I want to show? So, Colorado people have done a bunch of interactive simulations for teaching of science. So here is another example of, I can just show you, I can get these people going, I can run the simulation, and you can see it, and maybe I add, and maybe I can stop it before the end. No, I didn't. So again, all of this kind of stuff. So part of the value proposition, again, I will get to later on, is what I am in terms of partnership is how do we get more people creating things that are there. Let me see if I had anything else before we go into the creation experience. So this is the extensible architecture part I'm talking about, so we'll get to it. So let's go into the creation experience, right? So you've just been watching a wide variety of things. So you say, Anoop is just claiming that it's all simple. And, is it actually simple? How hard is it? So I'm going to create something on the fly for you guys. So this is just a regular PowerPoint deck that is there. I can go through it. So it's just animation. So, this is just a regular PowerPoint deck that I have. What I have done here is, if you go to home in this thing, there is a mix tab. So when you go to the site and you download, okay, you get this mix tab. And what this mix tab gives you is ability to record audio, video, and ink, which I will do. You can insert these quizzes, videos, apps that I was talking about. You can do screen recording for demos, and you can do screenshots, and you can export to video. This is also a video production tool, and you can upload to the web, which I will show you, what you can do. So let's go firstly to just the record part. So when I come here, I can select which is so this is the camera I have. It's just a webcam that I'm using, and I'm using my Sony tablet that is there, which gives me a stylus. So, if you're using a Surface Pro 3, and if you're into writing, you can get all of that. So here I'm recording both audio and video. Okay, so I will get the recording going. I'll, let's say, use a dark yellow and go here, and I can say hello. Okay, I can go to the next slide, and if you remember, there were 3 components, 1, 2, and 3, and then I don't know what the next slide was. So this is where we're saying there are a lot of features that are built into Office Mix to make you go. Okay, so I do this, I hit stop. Now what Mix has done is already taken this continuous video stream that I did, and it's divided it on a per slide basis. So we take you from the continuous video editing mode to a per slide editing mode. So I can look at what did I say on this slide. I can
And I
preview.
don't know what the next slide was, so this is where we're saying there are a lot of features that are built into Office Mix to make you go. Okay, so I do.
Now we allow you to edit on a per slide basis. This provides for extensibility. You go next quarter and you add something. So, so I can just in one individual example here, I can delete this slide recording here. I can say I want to do an audio only on this. So I'm just going to do that and say, Mix provides all of these different capabilities in terms of what we can do. So now I have an audio only recording associated with it, that is not changing. So let's close out of it for a second. Okay, so now you have a per slide conceptual video that is there. It's very different than video editing tools because you can redo. Also, these are just components. I can move it out here and I can decide to resize it. Okay, or I can go out here and say, this is too big, and I can make it smaller so it is not overlapping with it. So it's a very object-oriented, you just go and manipulate. So if you're familiar with PowerPoint. If you, as one example, let me do it after this one. You go and you say, imagine that you recorded your course one, this thing, and next quarter you say, oh, some great examples, new examples I want to insert. You don't have to record it all over again. So you just, create a new slide. So I'll just do a new slide. I'll make it a blank slide. Let me make it a blank slide and go to Mix, and I can record again, and I can just say, new ideas. Now this will be, when you publish, so when I was talking earlier about PowerPoint as your source code, so what you share with the people is not actually this PowerPoint deck. This PowerPoint deck is on your file on OneDrive, Google Drive, whatever you do. This is your source code. When you publish, you get the lesson. So you can be changing it around anytime. You can share it with a colleague who can author some other things, who can modify it, take a portion of it, include it in their own thing. So all of those things are possible. So I'll publish in a second, but let me take you to a few examples of the kinds of things, the interactive objects that I was talking about before you do. So you see this quizzes and videos and apps. So I go here to quizzes and videos. So you can go to the store where we have some number of things that you can do. Once you trust the apps, they come into this My Apps thing. So I can do a multiple choice quiz and insert it inside here. I can bring it, I can resize it if I wanted to. So, all of the controls are resizable anyway. So, what you're saying is nickname of Seattle, is what I had done. I can allow multiple, I can shuffle choices, and I'll just do A, B, add an extra choice, C. Let's say B is the right choice. I can preview it here. And there I am done in terms of adding a quiz is as simple as what I just showed you, and it'll appear, and there's a variety of things. And if you don't like the quizzes we have, you can write your own. In the sense new types, because it said the whole thing is really extensible. The next thing I wanted to show you was what it looks like to do a Khan Academy thing. So if I again go here, I go to Khan Academy and I say insert. So, let's insert a video. Any favorite topic from Khan Academy you would like? Would you like, let's do a video first? What topic? Name anything. In math, most of his content is math. We have all of the 4,000 videos from Khan.
Electron configuration.
Vector?
Electron configuration.
Electron. Let's see if he has any on something on electrons. Top left. Okay, there. Okay, so we have something. This seems like an old video. It's not super high quality, but we will insert it there. So, we have a thing. Let's go and do a Khan exercise. So Khan exercise. So we again go to Khan. I had an exercise on. I won't try and make it beautiful or anything. So, we'll just do exercises. Let's just do on matrix, and so I don't know, matrix dimensions. He has something there. Okay, so we will just insert it there. I want to show you, if once we do all of this, so, the other thing I was showing you was these simulations from PhET. So this is a place where you can go and do a simulation. So I'm really trying to, do the full deck that we had. This is the 4 simulations out here. So let's go and do that. I will maybe resize it a little bit to make it bigger. I insert it out here. What is the thing? I think the last thing I've said I'll insert is Phil Guo's lab. So I can go here again. I can, where is Phil stuff? There's Code Hunt, online Python tutor. I can go and, add a piece of code there, and then I can go and insert web pages. And what the web pages give you is actually a very powerful thing, which is that, you can find the many interactive things that are there as web things. So whether it's geometry or whether it's Wikipedia. Here I'll just insert the base Wikipedia thing because of time. So let's go and do that. And then finally, let me just record here. Thank you. And I'll just say again, hopefully you see this extensible architecture. So what we've just done is created a lecture. What do you do next? You upload it to the web. There are a few different things that you can do. Here it's going to produce a video too, so you can also produce videos you can post on YouTube, etc., and on certain platforms. So you go next. I did a check. And now basically it is uploading it to the cloud. So basically it's taking what we created that's still on your desktop or wherever laptop that is there. And in the cloud, the whole thing gets disaggregated. So the media elements get picked up. They actually go to Azure Media Services so that they can be streamed appropriately. There are other portions that are getting linked to Azure table storages, queries, and things like that. So you can get the analytics that I'll show you in a second. And within the 15, 30 seconds that we took, we have just created, this particular lesson that is there, and you can, I don't know what's today, July 15th, and I can, what do I say, faculty, you can edit it, you can do tags. You can also embed it inside your web pages, etc. also, so I can save this, and then let me just go to my mixes. So this is, we are getting into the portal now. Okay, so where we are now is in the portal. And the way I share actually is if you go to the details, the way you share it is it's like sharing a YouTube link. It's like sharing, something from your Google Drive, OneDrive. You just take this link and you can share it. And you can also embed it. You can embed the links. You can embed it in web pages, and I'll show you that in a second. Okay, so let's just look at what we created.
And go here, and I can say hello. Okay, I can go to the next slide, and if you remember, there were 3 components: 1, 2, and 3. That,
remember, we had gone to audio only.
All of these different capabilities in terms of what we can do.
This was the new content thing that we added.
New ideas.
And then we added a bunch of things. We added some quizzes, and I think B was the right answer, just in going quickly. What we had done, we had added a Khan Academy video on electrons.
In the last couple of videos,
and then we added a random quiz around matrices. And, I can get hints, and so the standard, all the interactive components work. We added the simulation, which I had shown you earlier. We added some Python code. We added a Wikipedia page that you can go across, and then we finally
just say again. Hopefully, you see this.
So it's really that simple and quick that you can go and create. And so then finally, I want to show you briefly in terms of analytics. So I'd created a version of this earlier on that is there, and let me just actually take you to this analytics. And the analytics that you see come from the form because there is a natural this thing of slides, because we are doing in slides, you say how many people came to each slide, how many views, somebody could have come to it multiple times, and what was the time they spent on the slide. So, this is a 34-second average person came and spent around, 155 seconds. You can look at that. You can look on it by user basis. On a per user basis, you can drill down into a given user and see how much time they individually spent on each, or you can look at how did they answer a given question. And by early next week, we will give you an Excel spreadsheet so you can, go and do anything with the data that you would like to do. Okay, so I'm going to go back to the presentation so we get a little bit of time for questions at the end. So, this was Office Mix. Requires a Windows machine. I know many of the faculty run Macs, so you're going to have to run Parallels or something else. The APIs for PowerPoint on Mac are different than on Windows. We can do that. You need PowerPoint 2013, to do this. The add-in itself is free. The Active Stylus is a nice thing if you're trying to do writing as you're doing, and most of us in STEM and things like that, writing is a fairly useful thing. It's totally available. All the cloud storage, all those parts are free. You just go and start partying. What are some of the usage things? So, certainly if you're trying to do online lectures, whether for MOOCs or SPOCs or just blended, or your TAs are doing, recitation sections, for any of that, you can go and do it. As I was talking to Andy Van Dam yesterday, so this thing was, he's going to make all of his students for their practice talks that they do and send to the prof to say, this is the way to do your practice talks. And the professors can mark it up. Very soon we'll give you personalized discussions that I'll get to. You can also be sharing. So, all of us go to conferences, we make presentations, but then on the website that we have, we only put the PDF file. Okay, why not post also your thing? So I want to show you an example here. I didn't test it before. So, this is Mary Maris, who's working with us. So, this is the Microsoft Research page. And along with the PDF that you have, you also post a summary. So instead of posting the full talk, what she's done is she's embedded just a 5-minute presentation out there. And of course, I can go to the presentation,
Hi, I'm Meredith Ringel Morris from Microsoft Research. And in this mix, I give a brief overview of some highlights of our research.
So, again, a pretty natural scenario in terms of what you can do to share, because you can embed. This is another way in which your students and yourself can take, because, communications is such, my personal belief is such an important part of what we do as researchers and faculty. To share it in a different form, to engage your audience in a different way, becomes really powerful and useful. And finally, these labs that I was saying, what like Phil Gua at Rochester has done to take the Python tutor and bring it, what the Colorado people are doing, design new types of quizzes, all of those things, for the particular topic field you are, becomes very interesting to do. How are we extending it in the future? There's a lot of things around slide level discussion boards. Most current things have, just a discussion board for the whole lecture. We want to make it so that your questions and discussions can be on a per slide basis, because again, slides are a very natural granularity with it. We are going to integrate it with popular learning management systems. How do you do note taking side by side as you're listening to the lessons? You're looking at this as a live lecture recording tool. So imagine that as I was doing this talk, I was carrying my slate around, walking around, and I had a lavalier mic or, a audio plugged into my USB of the laptop. I go, at the end of the lecture, there is a mix that you can share with the class. Okay, so the whole thing is recorded without needing anybody else, including all the ink that is there. We are enriching the platform for labs grading, things that can go on. I will actually skip the next slide, and given the time we have, open it up for questions. The way we are doing it for each of the sub-talks, we will do Q&A right after these. So we have 5 minutes if people have any burning questions. One announcement that actually I forgot to make is that right close to the entrance after you do the registration and you walk up front, there is a station where you can play with Office Mix and produce your own Office Mix. We are handing out 3 Surface Pro 3s okay? Later this evening, I don't know whether the end of the deadline is 3 p.m. or 5 p.m. And from what I've told is the number of entries so far is limited. So the probability of getting a Surface Pro 3 is moderately good, okay? Okay, so take your time, go and try it out, please. Okay, now, I think you'll enjoy it and it'll be fun. Yes?
So I think this is really cool. One thing I was wondering about is whether or not you thought about closing the loop. So as we start getting all these cool analytics, could we automatically change the mixes themselves to try to make them more effective?
So you're saying as you're getting the data to automatically...
Feed that back into the mix itself and say delete that slide or start reconfiguring these so that they can become better and better.
I think it's a great idea. We would like some more experience with it before we go and build in that features. So, if somebody like yourself, Sama, goes and tries it and says, here is the stuff that I'm doing manually, here is the part I would want automated, it's quite feasible for us to go and do that because, in the back end, everything gets, split into individual slides with audio, video, and things like that. So there's a lot of flexibility in what can be done. Yeah.
So this is great for sort of instructors to create. This is great for instructors to create sort of messages, if you will, for students. Are you planning to have students to be able to do collaborative learning, sort of beyond what the instructor is providing here, so that you have a team of students who might be remote who can then interact with one another? So
yes, so the 2 points. So one is, I hope it didn't come out as this is just for faculty and this thing. So one is students and graduate students should be using it. From my vision perspective, third graders could be using it after they go for a trip to the zoo, come back and tell a story back to their teacher. So this is just a brand new way to communicate with PowerPoint. That is kind of the broader thing, in some sense, flexibility. The second thing that you're talking about is very interesting. We know from actually the Stanford days, there was something called the tutored video instruction model, where 4 people watched a lesson together, and if they watched it together, the pause, play buttons were all tied together, and you could discuss. So we are actually looking into how we integrated with Skype and such tools, so you could set up a session, 4 people, in the same town or wherever are watching it together. They pause, they discuss, and they can do, and then we'll have, of course, the traditional discussion boards too. So great idea, but we are looking into it on how we make it work. What's the sequence? I'm forgetting the sequence. Well, you can go first.
I have 2 questions. One is there sort of... I have 2 questions. One is there non-linearity in some sense? Like if you take a quiz and then you achieve 2 out of 4 points, then you go one way, versus the other student who got 4 out of 4 can go another way.
Many people have asked us that, and I think it is feasible. So if you look at in PowerPoint, you can do links which take you to different points just internally within a PowerPoint. Or if you want to do it as a result of that, and you have, because the quiz itself is actually just a web service. It can be arbitrary. You can put in links out there, Surface links, when they do a submit, that take you to totally different presentations somewhere else, even to different websites. So again, the architecture supports a lot of generality in terms of what we can do. We are still, this has just been released for around 1.5 to 2 months as a preview. So again, a good idea. People have said, can you do adaptive content? Wonderful if you play with it, and we'll be happy to collaborate.
Great. Second question is kind of very obvious, similar to his question. Is this integrated with Skype?
Today on a Windows, you can run Skype on one side, you can run this thing on the other side. It's not tightly coupled. We are looking into how we might couple it so 4 people can be watching it together as if they were sitting around a table in some sense.
Particularly translation.
Yeah. Okay, yeah.
Hi, this is all very cool. I imagine that as this gains traction and pickup, a lot of the excitement is the low floor. It's easy to get started. If you can use PowerPoint, you can do this. I can really imagine demand from many quarters for a high ceiling on the video and audio editing, that while I'm most excited I can just do it myself, I don't need a videographer. For people who do then and hooked up with a videographer, they're used to all their very advanced controls, with a lot of mature software, and they may be pushing for you to be as advanced. So just
So I'm
feedback
saying,
for the
so
team.
the only thing I would say is we allow you to embed videos inside, okay, and that works. So I'll just quickly take you to, so we had Bill Gates do a mix for us, and I'll just play 15 seconds of it.
I often hear people say that poor countries are doomed to stay poor.
So, for this video that was done, means it was not done with a webcam or anything else, okay? It was done in a pretty fancy way, so, nothing prevents you from including such things.
Okay, and which is crucial, right? Because Bill Gates doesn't want to use a webcam, right? But there's also the opportunity to have someone come back in and really tweak the audio of something that was originally recorded with a webcam to do fancier transitions.
So today our proposal to you is do it outside and then bring in that media. Yeah. Okay, so instead of making the core tool super complicated and doing it inside, we're just saying is take it outside, bring it in. Okay, last question, then I got to really hand it off to my friends.
Yeah, so again, it's very nice, very easy to use. For publishing, you were saying you need to go and put it up on till the time you integrate it with LMS, etc. Is it possible to take the PPT and publish it locally on your university's site? So especially my lecture, I walk around, many professors would like to tape it and just make it available only to your students.
So you can make it available only to your students. So it's like the link that you have. You can share the link only with a small number of people, and it's not searchable, so you can make it so that the search engines won't discover it.
You still have to publish only on this site, not locally. You can't publish it on your server.
No, so the only thing you can do is, if you just want to use it as a video editing tool, video production tool, then you can get the MP4 and post
I guess
it.
my reason, many of us would want to host it on campus, so you don't need to go internet. There's bandwidth and other issues. I wonder if that's available or not.
So partly what I was saying is you have to take it to the video. The reason is the backend is actually very complex to give you the analytics and everything else. If you want the full functionality, you do have to have that backend. If you want limited, you can do something else. Thank you so much. We'll be around there. We are there in the demo session. Go and create a mix, and let me hang. I think we need to go to which laptop? PC2? You guys are which?
Yeah, I think so.
PC3 is?
Let's see.
You know which PC? Hey guys, do you know which PC I got to switch to? I'll do PC2 and see if that takes you there.
Let's see.
No. PC4. Okay.
Okay, that looks good. Okay. Can you hear me okay? All right. Welcome everybody. It's really great to be here, and especially having Anoop set it off. I think it's a very nice context for the work that I'm going to show. As Anoop said, we've been working on trying to think about how to help teachers with problems of grading at scale. So in addition to giving these lessons, what do you do once you get rich data back from students, especially when they're kind of open-ended answers from people? And this is joint work with my colleagues Chuck and Lucy here at Microsoft Research, and also Michael Brooks, who is an intern with us for some of this work. So there are many challenges to testing and grading at scale, and it's been very interesting, I think, over the last few years to see how the modern web technologies have been developing. So for instance, Office Mix have been really helping us with the broadcast side. So the one-to-many, getting the lessons out to people. We're getting really excellent technologies, great tools for being able to do that. But the many-to-one direction still has a lot of challenges that are left. And there's a lot of, in teaching, as you well know as teachers yourselves, there's a lot of critical aspects to that many-to-one feedback direction. And specifically, this depends on the type of assessment that you're trying to do. And not all tests are by any means created equal. If you look at the educational psychology literature, so on the very low end, and unfortunately the ones that are easiest to grade and often the go-to for MOOCs and things like that, are the true, false, and multiple choice kinds of questions. They're very easy to grade, but they're called recognition questions because all the student is doing is picking from a bunch of choices. They're pretty low in terms of educational value. When you move up the ladder, you move to what are called recall questions, so fill in the blank or short answer questions. And there's a pretty big step in terms of educational benefit here, because the simple fact of the student having to recall to create an answer from their mind actually makes them do a lot more and helps them with encoding knowledge. And there's a lot of work behind showing that. And then finally, the highest level and most effective kinds of assessment tools are, of course, the things where the student has to take the knowledge and apply it to a new kind of situation, to do a project, to do an essay, to apply it to new situations. And in this work, we're going to focus on this kind of middle tier in the recall stuff, and specifically on short answer kinds of questions. So another aspect that's really important when you think about grading, and again, as teachers, you already know this very well, there's a lot more to grading than simply assigning a score to each student. And if you think about this, like if you put on a purely machine learning hat and just said, oh, well, we can just figure out a way to optimize the score, that's really not enough in terms of grading. So when you look at how teachers actually grade, there's a lot of complex and individualized kind of attention that teachers do in grading. Different teachers will not grade the same corpus the same way, and it's important because they're teaching it in a particular way. They have particular things they want students to learn and absorb. And teachers often find it challenging in the process of grading to actually even maintain consistency for themselves. And I don't know if Eitan's here, but I remember talking to him last year and talking about the situation of how he often actually goes through a second pass through a student's papers, because once he goes through, he's like, well, now I kind of know what should get what grade for this paper, and now I go through and do it a second time. Another one is that there are important benefits for the instructor touching the student papers in both directions. So for the student, there's the opportunity to get really rich feedback from the professor about what's going on. But in the other direction, the teacher is getting this really important snapshot of student understanding. They're seeing the modes of things where, oh, this is what these students think. Oh, those students have it completely wrong, but they think in this other way. And that's a really important source of feedback for the teacher, because then the teacher has a chance to adapt and pivot. And like Emma was saying, it's an important step when a teacher can look at what actually happened with the students and say, how should I change my lecture for tomorrow or for next year based on how students did? And this, and so along with this comes the issues that you then see with if you're doing only the purely automatic grading, is that first of all, since none of those systems are 100%, you're always going to leave some answers ungraded or incorrectly graded, and the students are just kind of left to deal with what's potentially an incorrect grade. But I would say an even bigger problem is that the teachers don't get that very rich feedback. They don't get to see what's actually happening deeply with their students. So this led us to this question of, can we do something that is more like assisted grading instead of automatic grading? Can we leverage the best of human and machine to actually have them work together to do the best, to both get this rich insight and be able to assign grades? So the core idea that we had was that maybe something like clustering could help us deal with a large number of answers, but still allow for completeness in grading, giving good feedback to the students, and getting reflection in terms of what the students were actually doing. So there are a lot of details to the algorithm, and I'm not going to cover them. They're in the paper, and I'll show you links later, which you can get to the work behind it. But I'll give you a sketch of kind of how the algorithm works. So the basic idea is that you get a whole bunch of answers, hundreds or thousands of answers from students, and now, or it even could be dozens of answers from students. It doesn't really matter. And there is a distance function, a semantic distance function between answers that you've trained independently of this particular set, so you don't need to retrain for a particular question or answer that you've created. And that distance function tells you that some answers are close together and some are further apart. And based on that, you can induce a set of clusters. And within those clusters, you can induce a set of subclusters. And then once you have that, suddenly you have the ability to take high-level actions. You can now grade an entire cluster. You can grade an entire subcluster as being right or wrong. You can even go in and mark an individual answer and flip it against whatever the cluster or subcluster said. If an answer key is available, there's of course more that you can do. So you can apply that same semantic similarity measure between the answer key and individual answers or subclusters and clusters at a time, so you can actually automatically label some of these clusters or subclusters based on that. So this led us to a hypothesis and a metric. And the idea was that using this procedure, the number of discrete grading actions required to complete the task could go down a lot. So in terms of having to touch every single answer, now you could touch a large number of blocks. So we thought this is a good first way to kind of measure, is this actually reducing the amount of effort that's needed? So when we looked at this, and I'll just kind of point at this quickly, that indeed we saw an order of magnitude drop in terms of the number of discrete grading actions that are required. And this is with a synthetic ideal user that would always choose the optimal action and blah, blah, blah. So this is kind of a very early study. It also doesn't account for this very big question of, well, a grading action might take a whole lot more cognitive load if it's grading a whole cluster versus grading an individual item. So it's not really clear if this is enough. So this gave us a good idea about the algorithmics, but clearly the next step was to try it with actual people. So this led us to the process of actually trying to design and evaluate an interface for grading, because there are one of the big questions on the table not only was what was the amount of effort it would take a person to understand and grade a cluster, but also how would teachers react to clusters? Maybe they'd find it completely confusing. Maybe clusters and subclusters would just not be a good way for teachers to actually play with this stuff. So this led us to design a grading interface based on these clusters. And what you're seeing here is on the far left, it's somewhat like an email kind of view. So on the far left, you get clusters. And if you mark an individual cluster, in the middle column, you'll see the set of subclusters. And you click on a subcluster, and you see individual answers. And you can do grading at any of these levels. And the color bars on the sides are showing you what the grade levels that are assigned to the different ones, so correct or incorrect. And you see a level of grading, the progress in grading, and you also have the ability to give feedback. But rather than talk about this too extensively, I'm going to do a quick demo, which will hopefully work. Okay. So, so here we're looking at the question, we're looking at this question of who or what makes federal laws in the US. So we gave this to 698 Turkers, which was a fascinating experience in itself. But Turkers are very earnest workers. It's really quite interesting. They get really sad when they can't answer the question correctly. But anyway, so we look at what did they say were the answers, and this was all in the U.S. market, so they're mostly right. So we look at this big block that says Congress, and I'm like, well, Congress is right, and I look at these subclusters in here, and Congress or House, Congress, and maybe that's a little overly specific, but they did say Congress, so I'm gonna give all of these guys a pass, and I'm gonna say that's okay. Then I'm gonna go into a different particular cluster, so Senate and House of Representatives. Well, that's good, I like that. But when I look at the subclusters, Senate and House of Representatives, that's okay, House and Senate, legislative branch, that's fine. But this group said just the Senate, and that's not the whole story. So I'm gonna give them partial credit, and then I'm gonna say, both houses of Congress are involved. And by hitting return, I have broken the web, but in general, by having some web connectivity issues here. But what happens when I do that is with one stroke of the enter key, I'm giving feedback to those 16 people at once. So instead of, so horrible things are happening on the web. But the point is that, let's see if I can go back to that for a second here. The point is that by going here, I can very quickly, give feedback to a large number of people at once. But I'm going to give the rest of these people a correct field. I'm going to try. Well, okay, so I can give them the feedback of foo. But anyway, so now you can see that with a relatively short amount of time, I've graded now 62% of these 698 people, which is, and so it's fairly satisfying fairly quickly. You can go through and actually get a lot of grading done. At the same time, this is a demo, and it doesn't really tell you what happens with real people. So I want to go into some results of what we found when we actually gave this to teachers. So before I do that, I want to tell you a little bit about the baseline. Essentially, it's the same thing because we wanted to keep it as similar as possible. We just took away all the clusters. So essentially, the exact same interface. They get the same list of answers, same ability to give feedback. They just don't get the clusters and subclusters anymore. So in order to study what it meant to have this, whether it was helping people or not, we had a few fundamental questions we wanted to ask of the potential subjects who would be able to use this. So the first was, did teachers like it? Did they get horribly stressed out and unhappy with these clusters, or did it make them, make them happier? Second, what about efficiency? Were they actually getting the kind of gains that we saw in that preliminary algorithmic work, or is it all just a pipe dream? Was the accuracy affected? Were they able to grade faster, but at the cost of actually giving accurate grades? And then were they able to give the kind of feedback that we're talking about? And then were they able to reflect and find these modes of student answers? And so we did this by doing an online study of 25 college teachers. 25 middle school, high school, and college teachers, actually mostly middle and high school. And within subject study where both of them tried both interfaces on 2 different questions, and then we changed all the orders and all of that kind of good stuff. So to start with, in terms of the preferences, they did strongly prefer the clustered interface. And what was really encouraging to us was actually seeing some of the very verbatim, seeing what people actually said about the interface. To hear them say things like, on the left here, that they were initially thought it was going to be very complicated, but then they actually found that it was quite efficient and easy to use. The second one telling us how it helped them to actually identify student patterns and thinking. So the kinds of things we'd really like to hear them say. Next, I'm going to go briefly into this. This kind of gets complex, so I'm not going to go into too much detail here. But essentially what you're looking at here is in the flat condition on the left, so the baseline, and the clustered condition on the right, the progress of the number of items graded over time. So on the x-axis, you're seeing the time in minutes, and on the y-axis, you're seeing grading. And the thing I really want to call out is when you look at the characteristic of the curves on the left in the flat condition, basically they're plodding along in a linear manner. They have some rate of grading, and they just kind of go along, and you see some slope because they're just grading along at some constant rate. Whereas when you look at the clusters, there's a very different shape to the curve. You see these stair steps, and what's happening in the stair steps is that they're grading a cluster, or they're grading a subcluster, so they jump up by a bunch of answers, but then they're reflecting, kind of, did that make sense? They go into the subclusters of individual items, look for outliers and things like that. So they kind of move in this thing. But what's also happening is that, you look at the overall rate, and it's quite a bit faster here. It's a little bit hard to make a precise number because the nature of the grading is quite different between these two. And I don't want to go into too much detail here. It's in the papers. But what we did to determine the speed was we looked at the furthest point a person got in terms of grading, and then the first time at which they got there. So, so if you look at the flat interface, that looks like a line like that. If you look at the clustered interface, it looks like a line like this. It's not a perfect measure because they might have done some more reflection after that, but it tells you essentially what's happening in terms of the grading rates. And so what we found when we looked at both speed and quality in that sense, and again, I don't want to go, say too much about it. I think that generally one can believe that the grading under the clustered was faster. The exact number of answers per minute, is maybe debatable. But one of the things that we're really interested in seeing is that, okay, if people are faster, can they still be as accurate in terms of their grades, or are they missing a lot of key things? And this accuracy is done in terms of some gold standard grades we had, which had high agreement between other judges that looked at the same data. And what we found was that, in fact, there was no difference in accuracy when you're looking at the clustered condition versus the flat condition. There's this one person, this one teacher who really just didn't do the task very well. So, we still included it in the results, but this person clearly didn't try very hard in either condition. So just a few more things I wanted to point out. So one is that there was no difference, interestingly, in the median number of instances of entered feedback that a teacher gave in one condition for the other. So the number of things they actually typed in terms of feedback. But because the clustered interface was sending it to so many more people, the actual number of students who ended up getting feedback was a lot more in the clustered condition. So a median of 75 students were getting feedback versus 18. And the teachers were, had a number of things. I'm going to skip over some of those details. And then finally, one of the things that was most important to us is that the teachers really felt that this interface was better for reflection. They were actually be able to do a better job of actually getting information back from the students. and hearing them say things like the interface makes answer trends more easily identifiable. In another one saying that the grouping the answers into clusters help them spot patterns, to be more consistent in grading, devote more time to individual answers, was really heartening for us because this is kind of where we started in terms of what we really wanted teachers to get out of an interface like this. It was wonderful to see them actually telling us, telling us that they saw this in the course of the study. So with that, I want to wrap up this part of the talk. And I just want to kind of keep in your minds this idea that power grading is like a power tool for grading. And the fundamental principle, the design philosophy behind this was keeping the teachers in the loop, but amplifying their capabilities so they can handle larger classes. We don't want to replace teachers with automation. There's a lot of really core, fundamental, rich information flow from teachers to student and vice versa. And in all the work that we're trying to do, we're really trying to maintain those links as much as we can. So what we're doing right now is we're making power grading as a service widely available to teachers. And we're doing it through Office Mix. And we're also allowing people to upload their own data and try it. So if any of you have data sets of student answers or courses you're thinking of teaching where a tool like this might be useful to you, please contact us. Probably the easiest way is to just contact me at sumitb@microsoft.com. And also, if you're interested in the full versions of both papers behind this work and some video demos of how it works, you can go to bit.ly/powergrading to find all of that information. And with that, we have a couple of minutes for questions, and I'm happy to answer anything that people are asking about. Go ahead.
So I teach engineering classes,
Okay.
which have short answers, but you're calculating, you have some circuit or some other thing, you're calculating a set of answers.
Yeah.
Have you tried it on anything like that?
We haven't, and my guess is that it's probably not going to be great for things like that without a different kind of training data at the least. Like, I think that, so far we've kind of trained it in terms of semantic similarity for textual kinds of things, and I think that something that was focused on that kind of answer would really need to have a different kind of semantic metric that would kind of understand the difference between, different answers in a technical sense.
Okay. Then, if that's the case, are you interested in working with somebody who would like to get this?
Absolutely. I'd love to. If you have data that you could share with us, we'd be really interested in talking.
I'm teaching a class for 200 people, probably in fall. So.
Okay, cool. Yeah, love to follow up on that. Emma.
To follow up on that, I think this is a really cool idea, but it seems like the secret sauce is in the semantic similarity. So could you tell us a little bit more about how that works? And if that itself involves training with the teachers, do you incorporate that cost when you think about how much more efficient it might be?
Sure. No, that's a good question. So right now, I would say that because I come from a machine learning place, so I actually don't think that surprising, in some sense, the semantic similarity measure isn't actually all that awesome, but it still works pretty well. And because the thing is that, I think so there's a number of different answers. Because I think on the one hand, there is huge opportunity to actually improve that similarity measure, and especially to improve it in a teacher-specific way. To take it. If multiple people are grading a set, you could improve it over time for that set. There's lots of things that you can do, but and part of what again, like most machine learning people, we always scoff at things when there isn't that much data, behind it. And so far, this semantic similarity measure just doesn't have that much data behind it. So you could add more sophisticated models to the current data, but it wouldn't matter that much. But adding, for instance, your data for the engineering class, and adding a whole bunch of other people's data from different classes, you could actually make something that's very sophisticated. In terms of what it's actually doing, it's a lot of word-based and spelling-based features, the usual kinds of NLP features, and it's trained. And we've compared it to kind of past direct auto-answer grading things, and it performs favorably compared to those. But I don't think any of those really perform that great either. The thing that actually makes it so what I would say is that you kind of look at the 80s, 90s kind of auto-grading performance, which you know, from a teacher's perspective, is kind of wretched if you're thinking about auto-grading. But suddenly, when you can put it into a form where the teacher can still work with it and kind of complete the last mile, that's really what makes this work. So it's not really that it's a huge increase in terms of, you know, the auto-grading or the distance metric. It's really more putting into this paradigm of interaction and giving, and then having this, you know, having clusters which let people, you know, do that interaction in terms of groups instead of individual items that really makes it feasible and usable. Okay, yeah, let's switch over. Thanks, everyone.
So I'm Rakesh Agrawal. The title of my talk is Democratizing Learning from Textbooks. This is joint work with my colleagues in Silicon Valley, Srinivas Golapudi, Anita Kannan, Krishna Kenthapudi, and some of the people who have come and spent time with us as interns and visitors. So the basic broad question that we try to answer in this work is the following. You assume the availability of inexpensive, cloud-connected electronic devices. And I think second assumption is also important. We assume that the current textbooks content will migrate to these particular devices. So this assumption is different from saying we are going to write new content specifically designed for this particular medium. So we're just assuming that the current content will migrate to these devices. And then the question we are trying to ask was, can we enhance the experience of reading from these kind of electronic textbooks? So this is a one-slide summary of what we have done in this particular space so far. You can broadly think the work we have done into two broad buckets. One has to do with trying to build some sort of diagnostics, which essentially will try to figure out, are there portions of the book which in some sense are deficient? And I'll try to explain to you what we mean by being deficient. Second part has to do with taking a textbook and trying to enhance the content of this book by essentially mining the web. Okay? So in terms of deficiency, by the way, all this work is pretty algorithmic. Things that you might want to do by involving expert teachers, students is fairly complementary. But I'm going to emphasize trying to tell you what we are doing algorithmically so that you can sort of view it as the first order information which is made available to the experts. So when we look at deficiency, we look at deficiency within a section and then across the section. And roughly speaking, within the section, we're trying to identify whether the section has been cohesively, coherently written. In educational literature, sometimes this notion of principle of unity and principle of focus that has been qualitatively expressed, and we are trying to quantify those notions. In the case of across sections, we are essentially trying to figure out, is there a mentioning problem? Is the concept properly explained, or has at least been explained before it has been mentioned? And you basically try to define a metric for computing what kind of comprehension burden it's going to put on somebody who's trying to read this book, which has this mentioning problem. In the second bucket, we basically look at the current context. If you're reading at the section level, normally this is where we do the work. We try to find out if somebody is reading this particular section, are there other content which can essentially be used as a substitute material, or it can essentially be used for enhancing the reading experience for that particular section. So these could be other articles, these could be images, these could be the videos, and one can also think of adding things like PowerPoints and so on. Okay? The last piece is what we are calling references to prerequisites, and I'm sure you have gone through that particular experience where you reach a section and you kind of feel like, I've sort of forgotten this, or I need to refresh my memory about it. So we also give you, right in that particular section, pointers, if you will, to the concepts which are necessary for understanding this particular section. And these could be within the book, or it could be across the books. Okay, so this is sort of the broad view of what we have done. Most of it has been done completely algorithmically, and there's some interesting technical ideas what is happening behind them. in terms of the corpus that we have used for actually testing our ideas, we have used a corpus of books from India. These are the books from grade 9 to grade 12. If you go to a school in India, you basically, if you go to a government-funded school, you essentially study from these books. So these books are actually used by millions of students every year. The other thing we have done is essentially taken books, which are from, things like ck12.org, where essentially they are trying to create textbooks without any kind of copyright issues. So in fact, the selection of this particular corpus was dictated by this notion whether we can find content which doesn't have copyright issues. So we tried to work with material which was available with any kind of licensing or copyright questions. These books are mostly high school books, but we have looked across different subjects. Okay? We have tried the same technology on some of the graduate level books also, particularly molecular biology books and so on. We have a bunch of papers, and these papers are accessible from Microsoft Research website. Those are the citations we are looking at in this particular chart. And all these ideas we have now built into a prototype. And what I want to show is how this interface looks like. I wanted to do this thing as a live demo, but if those people are interested in it, I have my Surface with you, and I'll be happy to show you this particular demo. I mean, web is so unpredictable connection. I just didn't want to waste time trying to really run a live demo here. But these are the screenshots. And if you think about it, what is going on is that in the middle panel, which is what you see by default, is a faithful reproduction of the book. We don't mess up at all with the content of the book. Okay? On the left panel, which you can invoke on demand, essentially allows you to navigate through the book. And it's pretty straightforward. It's not that difficult, and you can sort of throw this away, and you don't see it. I think the interesting piece is the third piece, which is here on this side, on the right-hand side. And this is the place where we put all kinds of augmentation. What you are seeing here is the video augmentation. And again, it is available on demand. If you don't want to see it, you can turn this off. There's some sort of a button available, which essentially indicates there's some interesting content available if you want to see it, and so on. Now, here, this is a particular example where if you look at that text, I don't know whether you can see it, essentially what is happening in this particular chapter on atoms and molecules, there's this section about laws of chemical combination, and if you see this particular material, it is suggesting certain activities. Basically, these activities were the kinds of things I used to love when I was doing chemistry in high school. You take this particular chemical, try to mix this chemical, and then see what happens to those reactions. And here, they are suggesting, students, one of the activities they are suggesting is mix barium chloride and sodium sulfate and see what is happening. The problem is that you might not have labs, particularly in some of the economies. These labs are too expensive to have, and people kind of, they just basically, these activities are never carried out. And what you're seeing is that this is the results of algorithmically trying to find out, are there videos available which essentially show this particular same lab? And the one we are seeing here, this particular one here, it shows actually the video which essentially somebody is actually demonstrating the reaction between sodium sulfate and barium chloride. And this is what is available to you or a student to look at it. Okay? Here's another example of it. This is very usual that you look in a book, you have these static pictures, and this is about, this section is about magnetic field lines created by bar magnet. And these are sort of static pictures, but essentially, we look at this particular piece of text, we try to find out are there interesting videos available for it, and this particular video essentially describes step-by-step magnetic field creation in bar magnet. And you got to see it. I mean, I'd love to show it to you, that it's a very different kind of experience when you see this particular video rather than a static picture. So this is the kinds of things we are trying to do, and the idea is that suddenly your experience becomes richer, and this is totally under your control, whether you want to see it or not see it. Here's another, I mentioned that we are trying to do the diagnostics. And what is happening, if you can see at the top, essentially this is the kind of the Vignette interface, where you can choose videos, articles, images. In this case, it is showing, you're clicking on diagnostics. And these are some of the things, like it's basically saying what's the complexity, what's the kind of I'll say a little bit about what is the dispersion and so on. And the idea is the following, that you can actually go through this interface and look at where this particular problem or potential problem might be present, okay? So this is what we are trying to do, and the idea is the following, that if things like quizzes and so on, somebody wants to insert, that will be an additional panel that can be inserted here, and you can essentially keep increasing these particular panels depending upon what you want to do, and you can get much richer content. Okay? Now, in the same place now, we essentially have integrated this idea of getting the feedback from the users, experts, crowd, whatever you want to call them, which can suggest the videos. There are a whole bunch of things here which are important from a deployment point of view. You might want to sort of say, I want to restrict the content to come from some sources and so on. So those are all the things that can, that we have partially incorporated, and some of the things can be incorporated. Please understand that what we are doing essentially is a research prototype. It's not a product offering. So in the remaining time, what I want to do is to sort of tell you a little bit what is happening underneath. Okay? Clearly, I'll not be able to talk about everything, but I just thought I'll pick up 2 topics and again tell you some of the algorithms that we are trying to use, just to give you the flavor of the kinds of things we are doing. Okay? So I thought it would be good to sort of talk about this whole notion of how do we figure out whether a particular section is not well written, whether this is a section which requires some attention from the author of the book. Okay? I mean, in fact, it turns out that we would really like to make this particular information available. We have basically computed it for lots of books now, these statistics. Okay? So this is how we do it. I mean, not surprisingly, there's some sort of a learning model, calling this a probabilistic decision model. And in fact, frankly speaking, the details of this particular specific learning model is not important. What is the value really is what are the features we are trying to use. We're calling them decision variables. And there are features which are sort of, which essentially capture the syntactic complexity of writing. And there's something what we call dispersion of key concepts. I want to say a little bit more about this because this is something you might not have seen before. There's another interesting question here is the following, that how do we generate the training data for testing these particular models? I mean, the usual argument is the following, get the data from the experts. But I think there's a circularity in this particular argument because these books were written by the experts, and we're trying to figure out what's the deficiency on these books, and then trying to use experts to essentially give you the training data is a fairly circular argument. So we spend a lot of energy trying to figure out how to generate algorithmically the training data. And so some interesting ideas that you should look at that. So I want to talk a little bit about what is the idea of dispersion of key concept. And basically, it's trying to capture what colloquially you will hear people say, this author is all over. You basically have been scrambling all around. And the basic intuition is that if you have many unwritten concepts, then that particular section is harder to understand. And how do we sort of do this? And I'll just, you can write it declaratively, but I'm just going to tell you algorithmically how do we do this. So think you have 2 oracles. Oracles would be algorithms. One oracle tells you, I'll give you a piece of text, and you tell me what are the key concepts in this particular piece of text. The second oracle, you give them 2 concepts, X and Y, and this oracle will tell you whether these concepts are related. Given this, you can form a concept graph where these concepts are nodes, and there's edges if they are relationship between them. And it turns out that if you look at the edge density of this particular graph, then it's a good predictor of how dispersed the concepts are in this particular section. You want this particular graph, in some sense, to be dense. Okay? So how do we find out concepts? Again, just at very high level, you can use some notions in NLP. There's this notion of terminological noun phrases, which essentially are patterns of the form A star n plus. So you can start with this. There's also this intuition we had that, and in fact we did this particular test, we look at the concepts. For example, you look at the index terms in a book, and then you try to find out, are there Wikipedia articles corresponding to that? So basic hypothesis that the way Wikipedia has evolved, if there's anything worth interesting, there's already a Wikipedia article on it. We did some sort of a sampling test and so on, and we found that the coverage is extremely high. It's upward of 95% just by looking at the index terms. So we said, and this test was done about 2 years back. I'm sure the coverage has actually become better since then. So that's another way of thinking about it. The following, that you can use essentially Wikipedia articles as a guide to figure out what are the concept phrases which are present in a particular text. And you can then throw additional statistics on it, what we call conceptiness of a particular phrase and so on. In any system, you'll use a combination of these ideas. In terms of relatedness, you can look at the co-occurrences, which turns out to be pretty good. In addition, again, this idea that if there are two ideas or two concepts are related, there would be links between them in Wikipedia is also pretty powerful. And that's another way of getting the relationship between the concepts. So given this, you can form the graph and you can compute this. And I just thought I'd show you at least one result that when you apply this particular thing, so what are some of the sections which essentially, these are the books which have been used by millions of students. It's not that this is a first-time book. And you find, this is on forms of business organization. This is how the concept graph looks like. And it has these long sentences, you can read them, factors like capital contribution and risk vary with the size. And, if you read this particular sentence, it'll take you a little bit of time to understand what this particular section is saying. And this particular model is just flagging out these sections, okay? So again, the idea is not to pass judgment on these books, but to sort of potentially flag them so that the authors or publishers can look at those particular sections, okay? I want to sort of give you a little bit idea about how do we go and add the content selectively from the web. And I'm going to pick up this example of trying to find out in fact, it turns out it's a fairly general way of doing these things. It applies to videos, images, articles, and right now, our underlying implementation is using this across different media types. So the problem is the following, that if you try, how many of you have ever tried to do a search for try to look for a phrase or something which essentially involves 6 words? Has anybody ever tried to do it? What kind of results do you get? You basically get no result or you get total garbage. That's the kind of interesting thing about web, that unlike databases where you add constraints, you get better results, here the results become worse, right? So you cannot essentially take a section and throw it into the search engine and hope to find out anything meaningful. In fact, we did a whole bunch of experiments. You don't have to really try very hard. This just doesn't work. So here's sort of a play on the same idea. And I think there's some interesting theorems to be proven here, which essentially says, okay, find out the key concepts, and now you form very large number of queries. These queries essentially takes phrases and forms, terms using 2 of them, 3 of them, and so on, and blast them to the search engine. It's okay if you want to do it to the multiple search engines, that's perfectly fine too. But once you have done it, then you will get a rank list for any particular object, and you then go and do an aggregation, some sort of a voting on top of this particular results, and these aggregated results give you the relevance score for a particular object, and that's what we use for figuring out what object to show with a section. Now, if you do it, it turns out that this particular algorithm is somewhat myopic. You'll see the same object being displayed, same video being shown on different sections. So you want to run on top of it an optimization algorithm, which essentially is trying to maximize the sum of all relevance scores subject to 2 constraints. You want that object to appear, in a section only once in a chapter or a book, and you want a particular section to contain some maximum number of objects. And it turns out that this particular problem can be solved in polynomial time, and it actually really does help. Evaluation, just to give a sense for it, we have done some of the limited amount of study with real subjects. We also have done some sort of mechanical Turk study. And, I facetiously sometimes say I haven't seen many user studies which are not very successful, and arts is no exception. That's the best I can say about it. So I thought I'll end this thing by, since I'm talking, I have this opportunity to talk to a bunch of you in terms of what are the open problems that, some of them we are looking at it, but it'll be great if somebody is interested in looking at these problems. I just wanted to throw that list up. So one of the things I'm most excited about these days is to sort of figure out if we have these contents from different books, and I mean, more ambitiously, if you just have the curriculum, can we essentially create what can be called a learning graph or a knowledge graph, which we can infer from this? And the idea would be that the nodes in this graph would be a learning unit. So what's a learning unit? This is the kinds of things you want to cover in one it's in some sense the atomic unit of teaching, if you will. So in case of MOOC, this might be the video that you want to show. In case of you're writing a book, this might be the section that you might want to have. So the idea is the following, that supposing you have these concept phases, you have relationship with them, can you now figure out this particular learning graph? And I think this is the basic data structure we want to have, because once we have it, then on top of it, we want to throw the user model, which will allow users to follow this graph along different paths, if that makes sense. We are also interested in laying some sort of a social graph on top of it, because in many cases, people like to learn in a group. So how to sort of dynamically form a study group around a particular learning unit is sort of an interesting question. In fact, we have a paper coming up in KDD, which essentially asks this particular question, that what is the optimum group composition? Supposing you have n students, and you want to break them into subgroups of size k, and the goal is to essentially maximize the gain for integrated all the students, then what's the way to compose the groups? And I mentioned some of these things about synergies with the expert sourcing approaches. Once you have the interaction data available, that's going to be extremely valuable once you have the deployed thing to actually find out what are the difficult things and so on. Performance evaluation is a big question, and I think there are a whole bunch of interesting questions related to privacy, security, confidentiality, copyright, royalty sharing. So this is a vast opportunity for doing a lot of interesting things. So I want to stop here, and these are some of the references, but I just want to leave it here and see if there's any question that people want to ask. Sure.
One thing I was a little confused about is, are the results curated then by, are the results curated by some experts, or is it all essentially algorithmically presented to the user at kind of load time?
So what we have done is, actually I should have said a little bit more about the backend. So backend, we are sort of viewing it as a Microsoft Azure service. So you basically bring whatever article you want to bring at it, and as a result, you essentially see the augmented results. Now on top of it, you can go and edit the results. Okay? So that's the philosophy. We'll give you the initial set to work with, and then you can curate it.
Great, thanks.
Yes?
If you pre-filter the chapter or the...
Sorry, Ankur Teredesai. If you pre-filter the chapter with NLP techniques for text summarization, would the results be significantly different than doing it on the raw image itself?
So I think what is really going on is the following. We had looked quite a bit into text summarization. I just generally don't like to make an experimental technology dependent on another experimental technology. So if we have gotten the text summarization perfect, then it's a very valid question. I just don't want to have that kind of confounding going on right now. Okay. Other.
So we can end the session. All of us will be in the...
Emma had a question. Can she just get?
I was just going to ask if you've had a chance to check. So it was great to hear about the Amazon Turk experiments, but what about the actual learning outcomes of people using these things? Maybe I missed that, but have you had a chance to try it with students and see how this affects learning outcomes?
So actually, we are actively seeking people. In fact, we have an ongoing conversation with a professor who basically is going to start teaching this. He has taught this class for a couple of times, and we're going to try to use the textbook he uses in this particular class And that will be a really good test for deployment. It turns out it's kind of a little bit hard question. In fact, I had put this particular bullet about what's the evaluation methodology. Creating randomized control trial for these kinds of things is not that simple. And we actually wrote a paper which tried to sort of say, can we do these sort of randomized control trials at scale? And I think there's some interesting, challenging questions there. But we really would like to do this particular deployment. I think it's just getting to the point where we feel comfortable about, we didn't want to give it to the students. I mean, think about it. There's some ethical questions about giving an experimental technology, which is about learning and studying, and you don't have a good confidence on it, and forming really the students to use this particular technology. So we want to be particularly careful about not putting this technology in the hand of students in a real life setting unless we are reasonably comfortable about the results. But I'd love to do that. I think we are getting to the point where we are willing to work with some adventurous professors who want to try it out. Okay, great. Thank you so much for your attention. I'm going to be around if somebody is interested in seeing the real demo and so on. Please come by.
Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.